At 1 p.m., a van is 140 kilometers due north of a car. The van is traveling due west at 60 kilometers an hour, and the car is headed north at 50 kilometers an hour. At what rate is the distance between them changing at 3 p.m.? All right, so let's do this piece by piece. So I'm going to say, so at 1 p.m., a van is 140 kilometers due north of a car. So let's just get that on paper. So we have a van, call it V, and we have a car, and at the beginning, they are going to be 140. So we'll write this out a little bit further. So 140 kilometers. All right, so that's like starting point. And now the van is traveling due west at 60 kilometers an hour. So the van is moving west at 60 kilometers an hour. Okay, so now it's going to be somewhere over here. All right, and what we're going to say, I'm actually going to call this length from here to here, because I don't really have the length yet, right? I've just written down like the speed that the car was going. I'm going to call that W for west. That could just as easily be X if you like, but I'm just going to call it W. All right, so that's W. And then we have a car, so our car now is moving, it's headed north at 50 kilometers an hour. So it's heading this way at 50 kilometers per hour. So it's going to be somewhere here now, right? It's after that time. And we're going to call the distance from the van, so from here to here, we're going to call that N for north. Okay, so that's going to be from there to there. And now what we're after, what the question is saying is, how fast is the distance between them? So that would be this, right? This is our distance. So how fast is this distance changing at 3 p.m.? So at that time. All right, so hopefully that made sense. I think it'll come as it comes up again. I think we can make sense of this. So let's just write down what we know. So we know dN dt is equal to, and so that was this one, right? That was this 50 kilometers per hour. So 50 kilometers per hour. Now, one thing to be careful for in this, though, is we're actually like decreasing in length, right? Like N's actually getting smaller, right? It's getting closer and closer to this point here. So this will actually have to be negative, okay? Because it's getting actually closer to V there, right? And then we've got dW dt. And that would be 60 kilometers an hour. And that's moving away, so that's going to be plus 60 kilometers per hour. Looks like I wrote seconds up there. That should be hours. Okay, maybe you got that. All right. Now, what else do we know? Well, we know that we're interested in this happening 2 hours later, right? It goes from 1 p.m. to 3 p.m. So just for a reminder, I'm going to write time is equal to 2 hours. And what are we after? Well, we're after dd dt, right? The rate of change. Here, actually, I'll write dd dt question mark, right? That's the one we're after. So yeah, so that's kind of our starting place, our starting point. Now, one thing I kind of like to do is different ways to do it. Like I know everything I'm going to need to fill in my equation, but sometimes it's handy just to actually like figure out the equation, like with our derivative and everything else, and then you can look back at it and say, oh yeah, I needed that thing. So if that didn't make sense, I'll show you what I mean. So at this point, like what we're going to do here is I'm going to relate my N, my W, and my D. I'm going to relate all of those with Pythagorean theorem. So I'm going to say N squared plus W squared is equal to D squared, right? Okay. So then from that, I have a relation between all those three things. So let's actually just take the derivative of that and see what we get. So we'll have 2n and then times, and everything will be with respect to time now, right? So times dn dt. Well, that's good. We have that, right? dn dt. That's looking good. Plus, and then this would be 2w, and then that's dw dt. Okay, we have that one too. That's a good sign. Is equal to, and then 2d times dd dt. Well, hey, that's the one we're after. So I guess I could have wrote that down here too. dd dt was the one we were after. All right, now, but you probably noticed the problem there. What does it want for n, w, and d, right? Those are actual lengths. Well, what that's after, what we need there, is the length. We actually need the length n at this time. We need w at this time, and we need d at this time. Okay, so what time is that? Well, that's 2 hours later. So we can just do a little bit of simple math just to figure that out. So 2 hours later, what was the length of w and then d? So w, if we think about w, I'll keep that in black. So length w. Well, if you think about that for a second, they were moving at 60 kilometers an hour for 2 hours. That would be, I'll even write that so you can remember 60 kilometers per hour. And if we multiply that by 2 hours, then how far have we gone? Well, we've gone 120 kilometers. Okay, so that's my w. And I can do something similar for n, but we have to be careful. If we think about it here, right, it's 140 is my total distance here, so 140. And then we're closing that gap at 50 kilometers an hour. So 50 kilometers an hour for 2 hours, we've gone 100 kilometers, right? So we have to go 140 kilometers. So for my n, we're going to go, the whole thing was 140 kilometers. And we're going to subtract, right, how far we made it in 2 hours. So just to avoid confusion here, I might not write that down. But 50 kilometers an hour times 2, that's 100 kilometers, right? So I'm going to subtract 100 kilometers. So it's 40 kilometers. Okay, so that's how far n is, right? That's n here. Okay, we're doing good. So we got that one. We've got that one. And now all that's left, right? So I've got this. I've got this. I just need my distance now. So how do we find that? Well, we've really made like a little triangle there. We can sketch that back out again. So we've made a little triangle at this specific time, 2 hours later, where we now know that this is 40 and this is 120. So now we can just use Pythagorean theorem to solve for d at that time. So d squared is equal to 120 squared plus 40 squared. And if we solve this, we get d is equal to 126.5 ... All right, we get a few decimals there. We'll call it 126. Well, you know what? We'll leave it at 126.5. Let's do that. All right, so we have everything. We have everything we need. So now we can plug in all the variables that we now know. So we have 2 times n, and n was 40. And then dn dt. Remember to put the negative in here as well, right? Because we were closing the gap. It's getting closer, so it's going to be negative 50. Plus 2 times, and then our w was 120 times dw dt, which was our rate there, so that's 60, and this was positive 60, is equal to 2 times, and then our d was the one we just found, so 126.5 we said. And then what's left is dd dt. That's great. So now we can just solve for this. So if we plug all of this into your calculator, probably, we get 10,400 is equal to, we get 253 dd dt, and then just divide both sides there. We get dd dt is equal to 41.1. So 41.1 kilometers per hour.